All right, so in this module, we're going to be looking at persistent XSS. And now I'm just going to define some scope, define a scope for what you're going to be learning. Okay, so you're going to be learning what is persistent XSS. That's a good place to start with a persistent XSS module. All right, and also, what are common locations for persistent cross-site scripting? And also, how can XSS defenses in general be exploited? And we're going to be going into a live example with OWASP, their juice shop, and checking it out. So that's where you're going to get basically your hands dirty and dive right in. And also, learning to leverage npm audit to check for node.js vulnerabilities, okay, and also how to do how an attacker can leverage this tool to do reconnaissance on your application if you have a little information leakage. All right, so we're going to be going through all that as well, and actually you are because you're going to be discovering this, so it's going to be great. And also, we saw reflected cross-site scripting in a previous module. Okay, so now I'm also going to be doing a little compare and contrast here. Okay, so let's start to dive in. So previously we saw the reflected cross-site scripting. That is a non-persistent variety, all right? Now we're going to be looking at persistent cross-site scripting, and it's also known as stored XSS. So that's another name you might see it being referred by. All right. So persistent cross-site scripting. Now, it's typically stored in the database, all right? So for example, what's if a user signs up with the username of this, right, of this XSS payload? That would be saved, right? And also, I have seen this. I did some proof of concept code for a previous employer. We were in it. We had some third-party JavaScript on our site, and they were leveraging local storage in a vulnerable way. So I actually wrote some proof of concept code that would obtain persistent XSS, but it would be within the client or the browser's local storage. So that's actually really nasty because even it's persisted within the browser. So that can get bad pretty quick. Anyhow, so you'll usually see it being persisted in the database, but there are also other varieties such that can be persisted, say, in local storage. Okay, and persistent XSS is just very problematic, okay, because it can be easily shared, or multiple users pretty much can be easily injected within a site. So, for example, like a chat application where username, okay, say up here, is sent to multiple clients. So all this person would need to do with this malicious username is just log into a chat room, and then all the other clients that are logged in are automatically injected. Like that is very problematic in my book. All right. So, what are some other high risk areas? So, all right, functionality that allows users to submit HTML markup. Okay, for example, web forms. All right, that's a hot area. Also, comment fields. I think you kind of get the point, but these are all high risk areas. Okay, so persistent XSS versus reflected cross-site scripting. All right, so persistent, whew, much more dangerous, okay? Can attack all users of a site simultaneously. That's kind of the key, right? And doesn't involve really any explicit action from a user for that to occur. Like they could just be passively in a chat room, right? Now, reflected cross-site scripting often requires an action from an explicit action from the victim. Okay, and we saw this in the XSS reflected XSS module, where a victim will click on a malicious link with the XSS payload inside of the link, right? And then that goes out to the server. The server goes ahead and embeds that within the response. Then once that's in the response in the browser, that those script tags can be executed right by the browser, and then boom, that victim is injected. Okay, but that requires basically an explicit action, basically a link to be clicked on, etc. And this usually typically involves one victim at a time. Okay, so that's kind of the differences there between persistent and reflected. Okay, so Now it's time for you to get your hands dirty. So, assignment scenario. Okay, so we're going to be exploiting a persistent XSS flaw by taking advantage of an XSS defense. And just as a little bit of an aside, all assignment instructions assume Linux or just Mac OS. And as I said, we're going for the Juice Shop. So it's an intentionally vulnerable web app, all right? And I created a fork just with an extra statement in there that would allow this basically allow Juice Shop to be kind of leveraged within this one tutorial. So you can check out my fork here, check out the Persistent XSS1 branch, and also I went ahead and compiled that Docker image and put it up to Docker Hub. So if you have Docker installed, just simply just run this command and boom, your local environment's all set up. So let's continue with the first assignment. Okay, so the first assignment, try to obtain persistent XSS within the contact form on the site. So once again, this port right here, this assumes that you've leveraged the Docker command, right? Because it's listening on 3000. So anyhow, okay, so the input is go on to this contact page, right? And what we're going to be doing, make sure you leave a rating, and you're going to be putting the payload right here within the comment field. And make sure to get your math right. So anyhow, so you can go ahead and put in this payload into that comment field. Make sure to leave that rating. And then you will see the output within the customer feedback section of this link. So this will actually be the last bullet point. You'll see the payload being persisted here, or being shown here. Okay, so go ahead and check that out. Okay, and then after that, you can go ahead on to number 2. So I'll just pause for like a couple seconds. So continuing on, so given the output within that customer feedback section, all right, how is the application handling those cross-site scripting attacks? Okay, so that's just something to think about. And then within the context of this feature, right, within the contact form and whatnot, why is this a bad practice? So that's kind of the second part of the assignment. So feel free to pause the video, and then I'm just about to resume with the answer in a few seconds. All right. So actually what I am going to do is I'm just going to go ahead. I'm going to take this payload. I'm just going to do it really quick. So here we are. Put in the comment. Put in our rating. We have we have 20 right here. I hope I got my math right. All right. We go ahead, submit. I'm going to go over here to the about portion. I'm going to reload. I'm going to look at that last bullet point, and what do I see? Outside text. We could also inspect the source and see that, that's pretty much it here. So we can go ahead, inspect, and well, actually, I'm not even going to drill in. You can go ahead and do that. But basically, the idea is those script tags have been sanitized out. All right, and that's the item here. Instead of rejecting that unexpected input, the application is sanitizing it. Okay, and as we will see, this is very difficult to implement properly. This sanitization, it's very tough. All right. And as a little teaser of items to come, start thinking about this right here. How can this sanitization be exploited? And we'll get to that in a few, but just to kind of something to have in the back of your mind. So here's the thing. It's just a little bit of an alert here, okay? If input is unexpected, fully reject it, all right? And that's why this is kind of like the whole item we had back here with within the context of this feature, why is this a bad practice? Like HTML input shouldn't, I mean, who cares if that's inputted here in the contact form? Meaning you shouldn't be sanitizing, all right? You should just reject it. If it's this is not expected, HTML tags are not shouldn't be expected to go into that contact form. Given that, you want to go ahead and reject that input instead of trying to sanitize it, right? That's basically what I meant by the who cares. Okay, you do care, but just within the context I said. So, all right. Anyhow, okay, so let's go back here. Yep, there's no reason why HTML markup should be placed within that comment field. All right. So, XSS sanitization issues. All right. So, given the application sanitizes the script tags here, right? Can you insert anything around these script tags that would allow the XSS to continue? Now, it's kind of a, I mean, it could be a little bit of a challenge, all right? But this is what we're going to be investigating. And if you can do this straight off the bat, well, you are the man or the woman, okay? But anyhow, if you can't, we're gonna basically be looking at this and throughout basically. Well, let me get back to this. We're basically going to be exploring how attackers could find this flaw through some reconnaissance, and then the answer will be within the final assignment. Okay, so information leakage, assignment number 3. So through the browser, view Juice Shop's package.json. All right, so try that out. And unfortunately, this file is often easily available because people will say, they're like, this isn't a vulnerability. Okay, who cares if someone can see what packages I'm leveraging and what versions, like whatever. I mean, it's not a big deal. I mean, most people know I've heard this with WordPress or what people are like, well, most of the web is operating on WordPress, so they can just make the assumption that that I'm on WordPress. So who cares if they see my version information? Well, I mean those version identifiers can be really can aid the attacker in many ways. Okay, so anyhow, going back to the assignment from that aside. So try to find that package.json through the web browser. See if there's anything. See if you can kind of figure that out. And if not, I have a hint. All right, so here is the hint. I'm just going to give you a second if you want to pause. So, all right, now I'm going to continue. All right, so the hint is, and here is a piece of code or a statement within Juice Shop. All right, so and see if you can leverage this just to grab that package.json. Okay, so here is the answer. All right, so kind of go in through here and we see it, right? So right in within the root. All right, and here's the thing, we already kind of talked about the whole this isn't a vulnerabilities little things there, so we'll skip that. So, all right, now take that file that you just saw, okay, and name it package.json, and you're just going to save it to a directory of your choice. And as I said, you have to make sure it's package.json as what it's saved as. And then we're going to be leveraging this within the next assignment. Okay, so reconnaissance through npm audit. So first off, I mean, if you don't have npm installed, there's simple instructions you can follow through Google. But if you do, no matter what, if you do have it installed, the big thing here is just to upgrade to the latest, because npm audit is something that just came out relatively recently as this tutorial was being created. Okay, so after you do that, cd into the directory with the package.json. All right, and you're going to want to run this command within the context of this directory. Okay, this is going to create a package lock file that npm audit's going to leverage. Okay, then go ahead and run this command, and it's going to persist the audit findings, and then go through basically go through that audit.txt and look for sanitize HTML. And basically look through it, look through the vulnerabilities that are associated with it, and think about what vulnerability within it can be leveraged to exploit assignment number 2. So there's going to be some issues that are linked to the vulnerabilities. So kind of go through those and see. That'll be kind of a hint of how assignment number 2 with those things that can go around the script tags, what those things would be that would ultimately lead to a full basically compromise of the front end through a persistent XSS vulnerability. All right, so check that out. You can pause the video, and then I'm going to continue. All right, so let's go for the answer. So sanitized HTML doesn't sanitize recursively. Okay, so that's the thing. So you can check out these two items. Also within I have the resulting kind of audit right here, and you're going to want to check out this more info path is really helpful. But also you can check out these, and this is also the GitHub issue that is involved, and that kind of gives an example of kind of some of how this can be exploited, how assignment number 2 can be exploited. Okay. So continuing on, so we just did, if we're putting on our attacker hat, just did some recon, right? And we found that. We found the version, we found kind of the flaw. So now let's go ahead and obtain persistent XSS within that about page, right? So anyhow, the input will be within the comment field, right? And make sure to leave a rating. So give that a shot. See if you can construct the payload that you're going to put in there that will then pop up that alert dialog box. So give it a shot. You can pause the video, and then I'll continue. Okay, so here is the answer. All right, so I'm just going to go ahead and do this real quick. I just have it. Go through here. So go ahead, throw in the comment, 5-star. We love our juice. Okay, 11, so we have 19 here. All right, and okay, so boom. So let's go in over here, and boom, we have our XSS. Okay, so let's kind of dissect this payload a little bit. So what is occurring is that the app is taking a script tag pairing, and it's sanitizing that out, that sanitize HTML, right? And it's taking that out. But now it's not recursively sanitizing out the script tags that then come up, bubble up, so to speak. All right, so boom, that is the mitigation. That is how an attacker could get around that. All right, and this is an alternative down here that doesn't work, and this is just because that it's parsing based on tag pairing. So here it would leverage this. It wouldn't just sanitize this alone out, right? And this alone out. It would sanitize this whole pairing out, right? So that would not give us persistent XSS, right? So that's just kind of how some of these parsers work, right? Yep, they're looking for those pairings. All right. So summation, kind of ending up. So here's the thing. If input is unexpected, halt execution. Okay, don't try to sanitize. I'm being, it's hard because like I've been in those shoes where I've made some of these decisions, like in my career at some point. So I'm saying this with a level of compassion. All right, not being like some boot camp guy like don't do this, but I think you kind of get the idea. And also, the exploitation process started with harmless information leakage. Quote unquote harmless, right? It's actually very harmful. And also, NPM audit is your friend, okay? And here's the thing. So GitHub came out a little while back with security alerting. So if you add a couple of items to kind of opt in to a couple of items within your repo, you can go, they will look through your package.json, and I believe they do it also for gem files as well currently, and they will kind of give you some vulnerability information. And now it's kind of interesting. NPM, if you're doing an NPM install, it will bubble out kind of vulnerabilities as well, which is just amazing. So yeah. And so check out that link, and that will also be in the show notes or the module notes. And here's the thing. I mean, kind of one of the last takeaways is persistent XSS could give attackers code execution on all of your users' browsers, right? So that code execution could be stealing authentication cookies and sending it to an attacker-controlled domain, etc. All right, well, that's pretty much it. So thanks so much for joining me.